So let's look now at transforming a logarithmic function and finding the inverse of a logarithm. Second half of logarithms here. Now we always want to keep in mind that a logarithm is just a function. And like any other function, it can be transformed using all of our principles we learned about transforming a function. And we're always going to relate to the basic graph y equals log base b to the x. So always keep in mind the basic sketch of a logarithmic graph. Key points, you'll always be at 1, 0. Will always be at the base and 1, and always at the reciprocal of the base and -1. And we'll get this sketch of our basic logarithmic graph. And the other thing to keep in mind is we always have a vertical asymptote at x equals 0. So we always want to keep that in mind when we're sketching our function. Well, let's look at a sketch of this logarithmic function. And we want to compare this graph to our basic logarithmic graph, y equals log base 3 of x. And from this basic graph, we can get our key points. Remember our key points on a logarithm, base and 1, 1 and 0, and the reciprocal of the base and -1. And from those key points, we can now transform our function based on these two transformations. Well, x minus 2 inside the function tells us we have a horizontal translation. And remember, when we have -2, that tells us we're going 2 to the right, translating that 2 to the right. And +1 is going to tell us we have a vertical translation. And this time we're going up 1 unit. So all we have to do is take our points and transform them accordingly. Well, we just add 2 to the x. Instead of being at 3, it'll be at 5, and add 1 to the y, we'll be at 5 and 2. Same thing here, add 2 will be at 3 and 1, and add 2, now it's a little bit trickier with a fraction, but 1/3 plus 2 is really the same as 6 over 3, so we can think of it as 7/3 and 0, or you can think of it as 2 and 1/3 and 0, and there is our transformed points. The only other thing we have to keep in mind is our vertical asymptote. The vertical asymptote was normally at x equals 0, which means when we translate that, we'll now be at x equals 2, moving it 2 to the right. So let's do our sketch. Let's sketch in our vertical asymptote, which is at 2. So we'll have a dotted line at x equals 2. And from there, we can sketch in the rest of our points. 3 and 1 will put us right about there. If we go to 5, 2, 4, 5, up 2, we're about here. And remember, 7/3 is the same as 2 and 1/3 and 0. So approximately right here. And again, we're just doing a sketch of this. So here is our transformed logarithmic function. Just following that transformation, getting a sketch of that function. So let's try another. Here's our logarithm, and we're going to compare it to our basic log base 2 of x. That's our function, just base that is given to the x. And remember, our key points will be, in this case, 2 and 1, 1 and 0, and 1/2 and -1. And now we need to do our transformation of this function. Now what we have to recall, though, before we can transform this function, is we need to change it in a way that allows us to see the transformation. Well, that just means we'll have to take the negative outside of the brackets, do some rearranging, like so, And there is our logarithmic function with the negative factored out. That tells us we have a couple reflections across both the x and y axis, as well as a translation to the right and a translation down. So take a second and see if you can go from here and sketch the graph. So after a little bit of work, we can see there are the transformed coordinates. First reflect in the x and the y axis, and then translate 2 to the right and 1 down for each of those 3 key points, keeping in mind your vertical asymptote at x equals 0. The only translation that's going to affect that is the moving to the right, the translation to the right 2. Throw in your horizontal asymptote, make sure it's a dotted line, and throw in your key points, and there's our sketch of our logarithmic function. And remember, we're just looking for a sketch of that function, and then we could tell the x-intercepts, the y-intercepts, the vertical asymptotes, and a whole bunch of properties. Just trying to get a quick sketch of that logarithmic function. Well, let's try one step further, because when we have a log function, we may have to find the inverse. And remember, to find the inverse, it's always going to relate exponential to logarithms. One is always the inverse of the other. And we've found inverse functions before. Remember, we just found a step-by-step process. The first thing we want to do is switch or reverse the x and the y coordinates. And then once we have the x and y coordinate, we want to isolate, and this is where it's a little bit different. We're either going to isolate for the power or the logarithm, depending on what the question is. Then we're going to switch it. Switch from exponential form to logarithmic form, or if it's in log, switch to exponential. And at that point, we want to solve for y. And this will allow us to find the inverse of the function. So let's put that all together, and we're going to determine the inverse of this exponential function. Let's bring up our steps here, and we can use these values. So the first thing we want to do in this particular question, well, we don't have y and x, so we're just going to take our f of x and change it to y, keeping everything else the same, just like so. Now let's reverse x and y. X over here, we'll get 6 to the 3y plus 2 minus 4. That takes care of our first step. Now we're going to isolate for the power in this case. So we're going to get the 6 with its exponent of 3y plus 2 by itself, and that's going to move the minus 4 to the other side, making it plus 4. And at this point, now we are done step 2. We want to switch this from exponential to logarithmic form. So the switch, log, the base stays the same. The argument comes from the other side of the equation. X plus 4 is equal to the exponent, just like that. And now that we've done the switch from exponential to logarithmic form, well, now we just have to do some algebra and solve for y. So we can minus 2 from both sides. We'll get log base 6 of x plus 4 minus 2 is equal to 3y. And we can go one step further, divide both sides by 3. And that'll give us y will equal log base 6 of x plus 4 minus 2 all over 3. And there's our solution. There's the inverse of our original exponential function, but now it's in logarithmic form. Well, what if we start with a log? Same principles apply. Switch the x and y around. We'll get x minus 3 log base 6 of 2y minus 5. Now what we want to do is we want to isolate for the logarithm. In this case, it's already done. So we can just go straight to our switch, 6 to the, in this case, and I'm going to put it in brackets just so it's clear, x minus 3 will equal 2y minus 5. Now we just have to solve for y. So 6, those brackets aren't doing anything, so let's get rid of them. To the x minus 3 plus 5 is equal to y, or should I say 2y. And now we can divide both sides by 2. And there's the inverse. Y equals 6 to the x minus 3 plus 5 all over 2. And that's how we can find the inverse, to go from logarithmic to exponential or exponential to logarithmic. And we're going to do a number of these questions in class.